894 days. I love my job. Before that, I worked for Redis. Redis is a nice little data tier, and it kind of aligns with why I'm here. I had customers that were using Redis, and they were doing really interesting things with these Raspberry Pi devices in production in really interesting places, and that got me excited. Before that, I worked for Pivotal/VMware. I went through the acquisition. But yeah, this one is an interesting time. I was in a startup. Right after I worked for Garmin. I was at Garmin. Garmin Connect is their biggest software still today. I am proud and sad to say that some of the code that I wrote is still in production today. So a lot of my scar tissue comes from this, from the decisions that were made a long time ago that I wish I could go back and fix these things, because I still have friends that are working there. I want to help. But here, I got to make some of those changes. I got to adopt the new way of doing things. I fell in love with Spring Boot here. I got teased by Cloud Foundry here. When I went to Mobile Capital Group, mid-zero, I was like, oh, Cloud Foundry, that's what I need. That's what I want. I want to be able to push my app, and I just want to have all my logs, metrics, tracing, stats, scale, buttons. I wanted all of that, but I didn't want to deal with the infrastructure. Now, I didn't have the skill set to deploy VMs. I didn't have the VMware skill set that I needed in order to get that to production, so I used Mesos for product number one. Apache Mesos, anybody? Yeah? DCOS, that was kind of as close as I could get to the Cloud Foundry, cloud native way of doing things that I could. I knew that, I could handle that. Product two, we went to Cloud Foundry. And this is why I'm here. I fell in love with Cloud Foundry. Things were great, and I felt like I had a team, an extended team, on the Spring team. Spencer Gibb, the Spring Cloud Gateway, Spring Cloud co-founder, replied to a GitHub issue. I was like, this is amazing. So for these 985 days, I really felt like I had an extended team in the Spring team, and you should too. They're an amazing team. They're trying to do what's best for the community, and they're actually a really cool group of people. I'm in that group sometimes. You can get a hold of me here. This is my access. All of my links are on DaShaun.com, and I do a show. The thing, I had access, the way it worked for me when I was at MedZero is my PA, the platform architect, the person that was on the sales team at Pivotal. I would meet with him every week, and we'd go have lunch with the Garmin guys, because we all let's talk about what we're doing. And I would say, oh, you know what, I had this issue. And he would take notes, and then he would go to Spencer, and then the following week at lunch, he's like, oh yeah, by the way, I talked to Spencer. Here's what he said. That was awesome. I also thought it would be cool, if I could reach out to the Spring team every once in a while. So when we started on the team, 890-ish days ago, we said, hey, wouldn't it be cool if we had office hours? So every week, on Mondays, I know it's a bad time for this time zone, but we have a live show. We did one earlier today. We're going to share the news. We're going to give you the latest and greatest. If there's anything that, oh, hey, you need to be aware of this, we're going to let you know. We'll show you what's coming on the roadmap. We'll always go to, Josh likes start.spring.io. We like calendar.spring.io. Did you guys know this exists? Did you know this exists? Yes. Some of you, if you come to the office hours, we can see all the releases. In 2023, there was only 4 weeks in the entire year that there was not a release of something from the Spring team. Every week, most weeks, there's something being delivered from the Spring team. And there's a process. Yeah?
It's not public, shareable calendar.
This is public, shareable. So if you want to get notified as when things are coming out, right here. The other piece, if you're curious about what's happening and you want to stay aware, the release, Spring.io blog release, I think. Oh, there's a releases feed that you can subscribe to. So back in the long ago, I had automation that would subscribe to that RSS feed and say, oh, here's a new version. a new version of Spring Boot 3.3, go upgrade all the palms. This is how I was getting my automation done. And it worked really well. The upgrade process was really consistent. So consistent that I got a little lax. I was like, oh, they got it covered. Until, again, this was at Med Zero, until that one day when one of the dot releases broke. And we happened to have an investor meeting that day, and they're like, oh, it's broke. Oh, this is no good. And I had to fix things. But that's how I was doing it. There's a better way now. But I digress. So you have these releases. Let me go back here and say this. Thank you for asking that question. When you come to my house for dinner, if you leave hungry, that's your fault. I'm going to make you dinner. I'm going to make sure you get fed. We're here at Spring I.O., and if you've got questions, we're at dinner. We're hanging out. Ask your questions. I don't know where this conversation is going to go. I want to give you as much as I can. So, ask your questions. Don't leave hungry. Okay? Nods? Yes. How many IoT connected devices will there be at the end of 2024? How many? Actually, raise your hand if you think it's 5 million. Raise your hand if you think it's 6 million. Billion. Billion. 13? 15? 17? 29? See, I know what you guys are going to do. I knew, so I put that extra one in there. 17.08. This is the idea. There are 17 projected. Let's go here. Projected 17.08 billion devices. Right here. Is that crazy? I think that's crazy. Before I actually looked this up, somebody told me 5 billion. I was like, no way. This is an amazing number. So, how many of them do you think are using Spring? Of all those connected devices, how many? I'll pause here. And just this week, I'll tell you some of the things that were interesting places that you might find a Spring Boot app.
Light bulb.
What is it? Light bulb. Smart light bulbs, right? We heard that walking on Monday night, right? How many people use VMware's vSphere? Have you seen it? vSphere, like VCSA app. That's a Spring Boot app. Isn't that crazy? Like, all of these infrastructure teams all over the globe, they're like, oh, we don't know anything about Spring. You're using it every day. And then when we think about your company, your org, right? They're using Spring Boot, but in some of these places, they're doing really interesting things with Spring Boot in interesting places. And I'll share a few. What is edge computing? I said, hey, Spring Boot on the edge. What does that mean? I don't know. This is my friend, Andrew Clay Schaefer. And he says, who wants to argue about the definitions of made-up words? Right? Like, yeah. We don't need to argue. My whole idea here is, let's just talk about interesting places. Whoops. Interesting places where you could be running Spring. One thing I am confident in saying, especially now after knowing 17.08 billion, I don't know what the numbers are for VMs that are running in the cloud and data centers, but I don't think that it's growing as fast as the not connected, not data center, not public cloud. All the other things are growing much faster, and I'm confident in saying that in 5 years, the number of devices that are not in the public cloud, not in a traditional data center, is going to far eclipse all of the rest, public cloud and traditional data center. It's going to be eclipsed by the number of applications that are running someplace else. This is it. I don't have cloud money. I don't have the money to spend to run. And we were having this conversation earlier. I don't have the money to leave a dev environment up when I'm not using it. Why would I be paying for infrastructure when it's not being used? Nobody pushed a feature. There's nothing for me to test. Why does dev.dashaun.com exist? Nobody's pushing anything. Dev.dashaun.io. It does not exist. I'm going to be embarrassed if this is up. It does not exist. This is good, right? it shouldn't exist if I'm not passing something. If there's nothing on my pipeline, tests shouldn't exist, stage shouldn't exist until something's being used. Hear me now, the simulator, cheat code. That's the way it should be. You shouldn't be spending on stuff. Who here has unlimited budget going into 2024, 2025? Unlimited. Nobody has unlimited budget. Who was asked to do more in 2024 with the same budget? Yeah, I'd say that's more common, right?
Or do more with less.
What's that?
Do more with less.
Do more with less. Yeah, I get it. So, my trip here, I was like, oh, I have all these great ideas. I'm going to show you all the cool things. So I bought a bunch of new stuff. And if you don't know, my luggage got lost, and I got it last night. So, but last night I stayed up, I'm like, oh, I'm going to do a bunch of cool things. And then I got a little distracted. But yeah, we're here. It'll be fun. It'll be fine. So I'm going to start right here. And some of these devices that I have, I'm going to give them away. So these are just Raspberry Pis. These are $15 computers. I just told you I have Raspberry Pi money. I'm a big spender. So if you, right now, you have your laptop, you have your phone, if you can show me a repository that has Spring Boot 3.3 in it, you can come up and get this Raspberry Pi. That's the first one. Oh, we already have one. You better hurry. You better hurry. Here it comes. There's value in being on the latest and greatest, and it means a lot to me. So let's take a look. This is awesome. That was it. He stood up. Oh no! Oh, you better fix that. You better fix that. It's close. 3.3. It was 3. No, I'm not going to round up. It was 3.2.5. So if you got a repository, do you have one? Do you have one? No, just show me a repository that has a 3.3.0 Palm in it, and you can come up and you can have this Raspberry Pi. That's all there is to it. Oh, it's a race. Let's see. Look at this. Done. Congratulations. Oh, yeah! So, for some orgs, for some places in the world, that's a data center. That's production, right? Like, I know that we take these things for advantage, like, oh, hey, yeah, disk is cheap, compute's cheap, but not everywhere, right? Not in every circumstance. And look at me like an amateur here. So a Raspberry Pi in some places is a big deal. I'm going to go one step. No, I'll leave it there. That's what it looks like. It's a Raspberry Pi. I was going to show you some blinky things, but we're not going to do that. Those are the disks. So you're going to need one of these, an SD card, and that'll get you started. I default to Ubuntu, and I'll tell you why. The Raspberry Pi OS that you might think is the better one doesn't have a lot of the kernel changes. You have what? You have a 3.3 repository? Yeah, it has to be a GitHub right now. I can push it together. Okay. Nope, that doesn't help. So that's the first one. At the end, we'll do another giveaway. I got another one here. But I'm proud of you. We'll wait till the end. It's going to be different. It's going to be a different thing. I ran the Raspberry Pi imager. I set up Wi-Fi. So on this device, I said, hey, I'm going to connect to a Wi-Fi. But I didn't know what the conference Wi-Fi is. This is one of those cases. Like if I'm going to put something in the back of a room or in a conference, you kind of have some expectation of what's going to be there. One of the things you're going to run into with these workloads that you're taking to the edge is like, oh, do I have an internet connection? Is it stable? And I'm going to talk about some stories from one customer. They're deploying these Raspberry Pi devices, these Spring Boot workloads, out into fields. And in order to get an update on that software, to go and deploy a patch, to go, plug in a new SD card or whatever it is, $20,000 was how much it was going to cost between the company and the customer. $20,000 to go and put hands on a device. Right? Right? I have Raspberry Pi money. That's not. So some of these interesting things, like what do you do when you're a long ways away? You have workloads that aren't connected by wire. They're connected by Wi-Fi, for example. You have these workloads. One option is you have like a point-to-point. You can get a little bit further distance if you're doing a point-to-point with Wi-Fi. But if it's windy or something happens, a tree gets in the way or whatever, and those things decide not to be point-to-point, they don't connect, then what do? Does your workload stop working? What does your workload do? This company, this is, again, why I was excited, they were using Redis as a buffered queue. So the data, the metrics that they were taking from the oil plant or the municipal water, they were saying, hey, here's what's been happening while I haven't been connected. And when they got their internet connection back, here's all the things that you missed. And then that time series data got put into place where it was supposed to be. That's really cool. If you've ever used a time series database, that's one of the things that are kind of difficult. Most time series databases want you to have forward-moving clock. They don't let you fill in the gaps going backwards in time. Seems like a weird feature. It almost seems something as mundane as loading beans at startup, right? Like these are just those tiny little differences in the software that make a big difference. So, I'm going to make a switch here. This is what I would do. Oh, did I kill? Oh, boy. I'm going to go build this image because it took a while. And let's see, I needed to switch off. My phone's Wi-Fi wasn't going to allow me to build the demo. I wanted to show you, hey, there's no workloads on this app, but I don't have access to this. This is not connected. I'm going to go put this over here with Thomas. Just hold on. This is a Raspberry Pi. And I'm out in the field. So that Raspberry Pi has 512 megabytes, and it has 4 cores of ARM64. It's connected to a little battery pack. And there's devices where I could plug in my solar panel. This says, hey, let me charge that battery for you. And I can scan the battery, and I can say, hey, how are you doing on power? Like if you get down below 5%, I want you to just go ahead and shut down safely, and let's get your battery back up. And I want you to power up in 24 hours. Interesting things that we have to do when we don't have access to those devices. So that was the example. He's going to hold on to that. I'm building an image. This is good. This is actually working. But we'll come back to that. I'm going to switch. Again, we're in an interesting place. And the internet sometimes can be interesting. So what I'm going to do here is I'm going to say, hey, let's shut off my Wi-Fi. And let's grab my phone. Oh, my phone's right there, yeah. Actually, let's leave that there. Let's leave that there. And let's do this. I'm going to turn this back on. No, I'll do it this way. No, we'll do this one first. So let's leave that and say, hey, interesting places where you have internet. Not too long ago, I was flying. I was flying from, I don't even remember where, Atlanta to Kansas City. And on that flight, I said, hey, you know what would be cool? What would be cool is if I connected to the Wi-Fi on the plane. And I started up a Spring Boot app, and I published a service. So imagine, if you will, me, this laptop, flying from Atlanta to Kansas City. And I'm a geek. I have my laptop with me. I'm like, hey, this will be cool. I started up this process connected to the airplane Wi-Fi. In this case, we're connected to the conference Wi-Fi. But conference Wi-Fi doesn't give me access. I don't have a public IP that you can go and access, just like a plane doesn't. In this case, on the plane, normally I default to Cloudflare D, but Cloudflare D didn't work. And look at that. So Thomas already has the URL. Here it is right here. And what he did was, my laptop is connected to my phone as the camera. So he went to this URL here, and it takes a snapshot of the camera. But we're connected to the conference Wi-Fi, but that's a public URL. Like, how cool is that? So I just, without having to expose port forwarding or doing anything like that, and on top of that, I've got HTTPS, I've got it secured. I just gave access to my laptop that's not connected to my camera. And that's kind of cool. It's doing a snapshot. Here we are. So, interesting places, interesting use cases. Let's go back. Let's tell this story. Since we have a picture up here, it was 2019. I was working at VMware. And one of the sales engineers, Nevin might know this story, one of the sales engineers took a Raspberry Pi and put it above their sink. Above their sink. In their kitchen, they had a Raspberry Pi, the little wires running down, just like my mess here. And they took a picture of the sink every 5 minutes, just like we did here. Except there was a camera mounted to the Raspberry Pi. And they used a project called OpenCV, computer vision. Same thing I'm using here. The question came, oh, who sees the problem here?
What?
Yeah, I'm sorry. I'm embarrassed. Let's fix that real quick. I can't believe I did that. I'm embarrassed. I'm just glad my kids aren't here to see that. So let's do this. I'm going to jump over here while that shuts down. I'm going to say, hey, spring cubed, which is going to go run that open rear recipe to bring me back up to 3.3.0 because I've got kids. So let's let that run, and then we'll start that back up, and I'll continue my story. Camera, OpenCV, same library that I'm using here. This is a Java version of the OpenCV. If I can find it. Here we go. And they were taking pictures. And what he had decided, what he had configured was if there's any dishes in the sink, the house Wi-Fi is off. It's off. This is brilliant. This is amazing. But Raspberry Pis, the Pi, I think, or what's in my head is Pi was associated with Python. And a lot of the workloads, I've been a Python fan, or a Raspberry Pi fan, for a long time. And a lot of these examples and use cases were all written in Python. I was like, oh, this is lame. But it was right around that same time. I was going to the gym, and Dave Sire was on a chat. He was talking about a new release, and it was the Spring Boot build image. And in my head, I was like, oh, well, that's kind of cool. And there was a project, I don't remember what it was, like a Ninja project, but Spring Native was getting started. And we were talking about the GraalVM and the native image, and I called in. I was like, hey, or I think it was a YouTube chat. I was like, hey, Dave, could I do this with a Raspberry Pi? Could I build an image for a Raspberry Pi to take my native images to a Raspberry Pi? And he's like, yeah, here's what you need to do. Right. And I started to glue things together. Because I didn't want to write in Python. I wanted to use Java. I wanted to use Spring. And I wanted to go to production with Spring. So at that point, I have kids. We built Raspberry Pis, and we stuck the Raspberry Pis with a camera. We put them in their rooms. And in their rooms, I was taking pictures. And I was trying to do the binary classification just like our coworker. So I had a bunch of, oh, this is messy, this is clean, this is messy, this is clean. And then I was like, this is too many wrong answers. It was hard to do. So then I was like, what if I just simplified it to the bed? Is their bed made? If their bed is made, we're good. So in my house, a few things. I've done the data center thing. I had racks in my house. In my house right now, I have 2 internet connections. And all of my kids and my wife have their own VLANs. So if things get a little, oh, your bed's not made, I hit the button, and it's off. So the experiment that I did, it was only a couple of months, but it's an interesting use case that has completely changed now because of Spring AI. So my use case was, hey, who do the beds? And I did the binary classification, hot dog or not hot dog, right? Bed or not, made or not. Easy to do. That's been around for a long time. And Christian, when I was doing that, Christian was the guy that was opening up all the issues. Oh, we need to do this. So awesome that we have all of these years of experience coming into the Spring AI project. But that project worked. Kids are like, oh, how come my iPad's not working? I don't know, go clean your room. Now my iPad works, what? So I only did it for a couple of months, but it worked. My kids make their bed, okay? This is what I was doing. This is the kind of thing that I could put a little device this big in their room. They forget about it. It's got stickers, and they made it into their case. They forget about it, but now it's there, and I can do interesting things, right? So that's not still there. It was an experiment. It worked. It was fun. But now with Spring AI, the things that we saw with Spring AI, that whole example has changed. I don't have to do the binary classification. I can take this image, I can send it to OpenAI. Is the bed made? Is the room clean? And I can get a score. So, kids, when you see this video, yeah, that's what's going on. Like, make your bed. Make your bed, right? So this is an example of interesting places. I'm gonna go see if I have an image. I did something simple. Okay, I have an image, this is great. What I used the Spring CLI to just create a simple application that you and I are familiar with, MVNW. Oh wait, no, this is the webcam one. Let's jump over here. I made a demo here. I don't do all of the fast. Spring Boot run. Cool. This is stuff you're doing. There's been a lot of cool stuff. This is, it better be Spring, 3.3, right? We're in good shape. And it's gonna be on localhost 8080. Oh, /greeting. Hey, we're up and running, so good. Another one down. So that's just running locally. I did my development, but now I'm ready to take it to someplace interesting. Let's see if my Kubernetes cluster is responding. I didn't start it back up. We'll see. Fantastic. This is good. Oh boy. So we're coming. Let it do its thing. I don't know what's happening, but this is all running on my laptop. So I've got Raspberry Pis in my home. Let's see what the number is right now, because maybe the kid's bed's not made. In my home, if I hit this clients button, there's 183 devices. I don't know how many you have at your house, but I've got 183 devices. I've got 4 kids, but most of those devices are Raspberry Pis. I was in that role. I've had the data center in my house, and I know some of the things, and I lived the life of having to deal with data center issues. Like, I don't ever want my wife to say, the internet's down. So I have 2, and it fails over. But that gives me also 2 networks in my house. So I've got some that are connected to network A and some that are connected to network B. And there's Raspberry Pis there, and there's devices there because, again, my children will never deploy active passive. So when we deploy things, I'm going to put this into your ear. When we're doing small workloads, my experience was like, hey, like, can you do this? Oh, if you don't have 3 nodes, you can't be HA because that's the wrath law, and you have to have this. Okay, I hear what you're saying, but if I have a 3-node or 1-node Kubernetes cluster on network A, and I've got a similar 1-node Kubernetes cluster on network B, and they're running the exact same workloads, and they're synchronizing their data, active, am I HA? I'm not going to argue, but that's how I give myself some reliability, some high availability with $15 computers. So let's, again, like, these are cool things. So the $15 Raspberry Pi Zero is not going to run Kubernetes control plane node. It can, but it takes a lot of kernel tweaks and stuff. But it will be a worker node. All right, what does that mean? Let's see if we have an example. There's one in here. Here we go. This is $130 of equipment. It's a Raspberry Pi, a bigger one that has 8 gigs of memory on it. That's good enough for a control plane node. And this is where that whole conversation came in. He's like, oh, you don't have HA in your Kubernetes cluster. Okay, but I've got 2 of these. And I'm running the workloads to both. That should give me HA reliability, right? So this is $130-ish case, and the Raspberry Pis, everything included, and it's a Kubernetes cluster. It's running Kubernetes, running K3s. That's my default. I put everything out here for you. I want to share. DaShaun-cloud. Flux. This is my GitOps. If you want to deploy something to my cluster, you want to deploy stuff on my Raspberry Pis, it's pretty easy. Here's my clusters. Here's the cluster that we're looking at right now. Kaiju is the name of this laptop. Here we are. Here's all the stuff that's deployed to it. This is a public repo. We have our Spring Office Hours, and we have people in our Spring Office Hours community that are copying this pattern. And we're learning from each other that this is a way that you can deploy cloud-native workloads, HA workloads. If you've got multiple places, I can put some workloads over at Dan's house. He's on a different network. Then we're geo-separated. And we can connect and do some really interesting things with low power, low cost compute. And if you want to join, if you think that that's cool, all you do is you go over here, and this is a new project. You sign up, you say, hey, I think that's cool. You add your name to the list, and you create a pull request. Oh, this is awesome. And I give you a path. So this is a really recent experiment. But some of those areas where you don't have access to a cloud, you don't have the $5 a month, maybe you're a junior developer, and you're trying to figure out, how do I get to be a senior developer? How do I get to have things running in production? I'm here to help. So you sign up, you say, hey, I'd like to be onboarded, like Eunice did. I got Eunice an org name, and here's the steps. Like, just do these things. All I'm saying is get a application deployed. Oh, that's okay. She didn't do anything. The test is actuator health. So Eunice, who I've never met, just deployed. She did a git commit into a repo. My pipelines take that git commit and do the things that it's running in my infrastructure. So build, sign, seal, deliver those native images because I'm putting it in my house with my kids. And let's run it. So how do I do this? Right? How do I plan on doing this at scale? Let's do a new window with basic, right? So you can see it. And can I SSH home? Oh, actually, I don't even need to go to Ampere. I should be able to go to Juice. And these native images, these small native images we learned yesterday, they start up fast. They have a small footprint. This is a 512 megabytes device. Let's do kubectx. And let's do that experiment one more time. And here's Eunice's. It's terminating. It's scaling down. So that Spring Hill Gateway, that's kind of the default. That's what we're going to onboard you to because I'm going to send all the traffic for her domain, uniceb.org. I'm going to send it to her gateway. And for her to route traffic, she's got to use that Spring Hill Gateway. So it's easy for me as a platform person, right? To say like, all you got to do is git commit. You follow these conventions, you can ride my ride, and you can go. But I'm building these native images. So that's shut down. We can go back and look, and I can hit refresh. And again, it started up. It's running. One instance is up. I gotta do this. Hello. It's kind of resizing funny. But that's the idea, that I can deploy your workloads. I can deploy these workloads, and hers has been up for 22 seconds. Scale up, scale down. So this is how I'm trying to learn. I'm trying to run production workloads just like you, but mine are on Raspberry Pis. And we're going to deploy those Raspberry Pis to interesting places, like my kids' rooms in the attic, and the plants, and all that good stuff. So let's go back. I'm going to pause. There's some interesting places, right? Interesting concerns. Let's go back here. Let's see if we can find this device. Oh, I didn't do this part yet. We're going to switch off the internet, and I'm going to now plug in my phone, and I'm going to say, hey, this is just like I'm on a field where I don't have great internet, or I'm in a plane, or whatever it is, whatever the case may be. You don't always have great access. Well, what are some of the things that you're going to run into? So I'm going to go over here, and I'm going to say, hey, you know what I want to do for here? Whatever the situation is, we're going to do some interesting things. We're going to go and turn on our internet sharing. And I want to share the stuff from my phone. I want to share it through Wi-Fi. Sharing was what? Oh boy, I don't know what the answer is to that. How does this? I think we're good. Wi-Fi, done. What could possibly go wrong? I gotta hit the button. All right, so now hopefully this changes, and we're taking the internet from my phone, and we're gonna broadcast it through my laptop's Wi-Fi. And hopefully the device that Thomas is holding on to will join that Wi-Fi. What could go wrong? Because we want to deploy something to someplace interesting. It might take a minute. But we validated, hey, we have something working locally. Now what we're going to do is we're going to say, hey, I want to build that image. So what am I going to do? I'm going to build a native image. I'm using Spring Boot build image with the native flag. Oh, hello. To build that image, right? You hear me now, listen to me later. Friends don't let friends use Dockerfile. There's no Dockerfile in this repository. I'm going to take the advice. You heard yesterday about all of the new efficiencies that are coming with Spring. One of them being the class data sharing. The way that we build projects, build Spring Boot apps inside of build packs is the best. It's all the best practices. The number one question that Dan and I get asked every week is, how do we learn the best practices? Everyone wants a checklist. Number one on that list is use build packs. Don't let your friends use Dockerfile. If somebody hands you a Dockerfile, you bat it down, okay? Build packs. Even if it's a COBOL build pack. You don't want a COBOL Dockerfile. Use build packs. Get those practices. What could possibly go wrong? Wait, we should be running, right? Again, it's the switching of the things. There's interesting things that are happening, and it's okay. Because we have a backup plan, right? I didn't expect to have my Raspberry Pi devices here anyways. My network didn't jump up yet. Let's see if we can get that going. I don't want this one, though. Let's go back. We're going to flip this button, and we're going to try this one more time. Turn it on. Let's see. And we have other images, right? I have Docker images. This one that I was building 21 minutes ago. Are we comfortable with that? I built it. We're going to push it. Oh, look at this. I got a weird, let's do this. Docker tag. We're going to rename it. DaShaun com.example.spring io v0.0.0.not a git. So you're asking, like, what is all this about? If you're going to ride my path of production, the way that you tag your releases, it's with your git tag. So you don't have to mess with versions in your files. You just put a git tag, and my build process is going to build based on that tag. I can't show that right now because the Docker's not working, and that's okay. But if I had said, hey, tag v0.0.1, the image that would have been generated would be v0.0.1 from that tag. And that's how my path of production works. So that's what that is. And then it says, hey, for your architecture, this one's going to go to ARM64. I like to go and I like to have all my friends have workloads. So I build native images for ARM64 and x86. But we're talking about ARM64 today. So I can build both of those and I can glue them together in a Docker manifest, and I can just say, hey, go grab this image, run it on the edge, run it on the mainframe, wherever you want. But you have an image. So we're going to tag this to just DaShaun Spring IO 1. Docker push DaShaun Spring IO 1. Now this is not working, but that's okay. Imagine a demo that worked. We're going to go grab one of these. Well, the internet doesn't want to cooperate. Let's try this again. So the kids have made their bed. My personal hotspot, hey, it says it's going. Oh, and look at this. So now it's being shared. Let's see if we can hit this. Let's just make sure we have internet. Oh, it's going to go and stand up. Good. We're connected. And now, let's see if we can find that Raspberry Pi device that's not connected to anything. In order to do that, hello, I'm going to say ARP-A, and I'm hoping to see, I don't see it yet. This says it's sharing. That's good. We'll see. These are the interesting things. But ideally, that app's going to come up. Is the battery on? Maybe?
Yeah.
Oh,
Should I try to turn it off?
yeah, there's a button on it. Turn it off, turn it back on. Some companies that would cost $20,000, right? Interesting places, internet-connected things, these native images can be deployed to these $15 devices. And I would like to show one of those. We'll see. But now that I have this, we'll pivot just a little bit. We'll see if we can get a green light to flash on that thing. And on my laptop, I'm running things. Oh, I've got Olama. I got things that are running on your laptop. It didn't seem like we could do these things that long ago. Like 5, 6 years ago even. It didn't seem like I could run hundreds of workloads on a 16 gigabyte laptop. Maybe that's not the edge. Again, who knows? But I have these interesting patterns that I can do today, and it's up to us to take advantage of those patterns. So this one, DaShaun-IO, that's that same convention, same as unisb.org. If I go to intro.dashaun.io, this is using Cloudflare. Again, I'm connected to now my phone's Wi-Fi. Let's see if it works. So it's now connecting to Cloudflare, and then Cloudflare said, oh yeah, I got a tunnel to this laptop through this phone, and I stood up. So now here, oh, did it go someplace else? Let's try that again. Why don't I see it here? I expect to see intro, service stand up. But that's okay. Let's go take a look and see. Yeah, why did that get, I'll bet you got cached. Oh, this isn't going. So my Cloudflare ingress is not working. That's okay, this happens. Oh, this is exactly the case. When I was on the plane, I was trying to use Cloudflare. Cloudflare can't sustain that bidirectional connection. So this is another example. When I switch to my phone that's on the roaming data, Cloudflare is not strong enough to sustain that bidirectional connection. Let's go see if ngrok is still. What do you think? Let's go see if ngrok, because this is one of those interesting things that I found was like, hey, they're not all created equal. No, ngrok's not connected either, so maybe it's my phone. My demos didn't go the way I wanted them to, so I'll pause right here. There's a lot of interesting things. Power is one of them. I talked about power. We've heard green computing a lot this week. All the efforts that Spring is doing to make this green computing. I've got clusters of Raspberry Pis that replaced Dell R710s. The fans would keep you up at night, right, if you've ever been in a data center. The places that we're taking workloads is changing constantly. And we're going to run into different things in different places. Like, hey, do I have an internet? One of the other things I want to show is like, maybe I don't have a bidirectional connection to some exposed. Maybe I don't want things exposed on the public internet. Maybe I want things only through a VPN. And I want to switch. I want to say, hey, don't call me, I'll call you. Let's keep going. These are the steps that I took. Like, hey, we'll skip. I use K3s, Knative is good. Docker also works. We did, I talked about Cloudflare and ngrok. Hey, this didn't work. It worked the first time, didn't work the second time. I did the webcam in the cloud. Like, that's pretty cool. This is one thing that's cool that now I just looked at this week, and it hasn't been updated, but it's a cool project that we get from Spring and Micrometer. The idea is, maybe I don't know where that device is, but I still want metrics from that device. And instead of that device calling home, or that device having an exposed URL that I can go and call, right? If I'm sending these devices, if there's millions or billions of these devices, maybe I don't know where they're at. So instead, I set up this Prometheus RSocket gateway, and I say, hey, device, when you're up and running, I want you to call me when you have internet. When your internet is active, call me, and then we'll open up that bidirectional RSocket so I can go and grab your metrics. Or I can update the software. You just call me when you have internet. We'll open up that connection, and we'll do it that way. Cool stuff. That's the thing that I really wanted to get to. So let's go back. And we'll pause there. So when you came in, how many people had Raspberry Pis? Awesome. What are questions? What do you have questions about Raspberry Pis? The ones that I heard earlier were like, hey, how did you get the ingress? I addressed that. Power. What kind of power are you doing? When I have multiple Raspberry Pis, the way that my clusters are set up at home is I have one anchor hub, and I have one low power switch, a ubiquity switch, so I can see all the traffic. And they are connected into that one power strip that's a smart power meter. That power meter emits MQTT that I consume. So even if I just power things on, I can see how much power I'm using. All of those Raspberry Pi clusters have 4 nodes. But I have Raspberry Pi clusters with Raspberry Pi 3s, 4s, 5s, and then potato Pis, lay potato, doing the same thing, all ARM64. What are the other interesting things? Power, connectivity. What are some other interesting things that you're like, can I run Spring Boot? Yes, you can. What are some questions you have about Spring Boot on the edge? I have not tried. So Pico in Spring Boot. So this is a great question, and I heard that yesterday. There's a smaller device. It has the EM3040 or whatever. It's a smaller processor. It doesn't have a kernel. We can't take our native images to that because it doesn't have an operating system that we can run. That's a real-time, different setup. ARM64, the same image that I build on my M1, I can actually deploy on my Raspberry Pi because I'm deploying it I'm building it inside of a Linux container. When we're building these native images, remember it's the operating system and the architecture. I can't move those native images around like I can with bytecode. So this is a balance and a trade-off that we have to make. But if you've been paying attention, RISC-V, another architecture, is available, and you can build native images with RISC-V. So pay attention, stay tuned. Maybe we'll see multi-architecture RISC-V soon, maybe. But right now, there's no real clouds or enterprise that are using RISC-V yet. ARM64, if you haven't heard, in some places you can save half. Same VM size, same cores, same memory, half the price by switching to ARM64. And for some of your Java Spring Boot workloads, you'll actually get better performance. It depends, but it's worth investigating. Any other questions? Remember, I don't want you to leave hungry. You have questions? Yes?
Managing Raspberry Pis on like CT NAT, sometimes on 4G or Starlink, how it's on IP.
Yep. So, same thing. The monitoring. How do you monitor these devices? Maybe the IP changes, the DHCP changes. That's an important issue. I tried to kind of point that out, like, hey, I might not have great internet. I'm not going to fiddle with it. We can do that down at the booth afterwards. But we might not always have great internet, and you have to think about your workload and how you're handling that. The RSocket proxy is a great way. Like, oh, hey, I have internet now, but when I don't, I don't. But when I have internet, call to the mothership so that I can be monitored. That's the pattern that I like. And there's tons of others, but that's the one that I lean into because it's affordable, it's easy, and just like most things in Spring, yeah, it's easy for me to do. I don't have to think about it very much. Good question. Any others?
Can you control the drone with Raspberry with Spring Boot? And for which reason you need to use Spring Boot to control the drone?
So, when I worked at Redis, one of the things that I realized was that latency matters. When you guys were watching the drones, did you see how some kind of took a millisecond longer to get in line? Like, it's those tiny differences that matter, right? Those devices were probably not running a kernel. They probably were closer to real time, but still, milliseconds matter.
Is it fast enough to properly control the drone with such application?
Yes. Yes, the answer is, I believe yes. I haven't done it yet, but there are drones that are powered by Raspberry Pis. So, yes, there's a project called the Pi4J Starter that's not yet native, and I take all the responsibility for that. Pi4J. And this oh, am I gonna have internet? This project is basically a Spring Boot starter that gives you access to all of the control pins, the GPIO control pins on the device. So I have one more device to give away. So all I want is a commit. Who is willing to take Spring Boot and put it on this device and report back that they have Spring Boot working on this device? Come on up. Hey, thank you for coming. My name is DaShaun. I'm a Spring developer advocate. I like to take Spring wherever I can. I don't have cloud money. I have Raspberry Pi money. Thanks. If you've got questions,